All right. I built a coding agent for essentially Kaggle environments. I am sort of in love with Kaggle environments as a training ground for interactive coding, especially for data science. So first, what I built, this is basically like a little code interpreter that works natively inside of Jupyter notebooks in Kaggle environments. So the idea is if there is a Kaggle notebook somewhere that can be run on Kaggle, it can be run in this environment. And this agent can make changes to a notebook, it can create a notebook, it could manipulate a data set that you download from Kaggle and find some insights for you. And also, very interestingly for me, it could generate fine-tuning data for chain of thought reasoning on small models. So just a little demo of what this is. Here's our agent, we're gonna run it. We are running a Kaggle Docker image or Docker container. So I'm gonna ask this to do something really simple and we'll just watch what it does in this notebook. Okay, so it's asking me to paste some Kaggle download code. I'm not gonna import anything, I'm just gonna show you right now what this does on its own. So what should I do? Show me NumPy A range. And then this is thinking of what to write in the notebook. And we'll see very slowly, because I haven't added streaming output. Oh, we'll see it wrote something. And now it's running its notebook so that we can see its output. That'll take a couple seconds because these environments are ridiculously slow. Oh great, we got an output. So it looks like A range gives us NumPy array from 0 to 11 exclusive. So so then we can do lots of other things, right? We can go really ambitious. We could ask this to, let's say, train an MNIST classifier. Train. And then it will chug away. Now this agent, it works reactively. So it writes code, it can edit code that it's written before, it can read error messages as they pop out. And the idea is that it takes a goal, it tries to achieve it that you specify, and it will write the code wrong. It'll make errors, it will reference variables that don't exist, then it will have errors contained within this notebook when it runs it. And it will correct those one by one. And then eventually you will have something that looks like what you asked for. Now, while this runs, because it's ridiculously slow, I will show you what my dream is for what this will become. So right now I'm taking a notebook on basically nothing and asking it to create something. But I could also have taken a notebook on any one of thousands, I think it's tens of thousands or hundreds of thousands of public notebooks. And then I could have, like an example of this is a very popular beginner data set, Weedle's Cave. So you see they're doing a bunch of exploratory analysis, they're trying to take some statistics. And it's very interesting to me to make interactive llama to do reasoning in chain of thought. So one way we could make this is we invoke a chaos GPT. And this chaos GPT, it just sort of wants to ruin your day. I've told it, you are a Jupyter sabotager. You have been asked to introduce bugs into a Jupyter notebook. These bugs should preferably lead to errors later on in the notebook. So the dream here, and I cannot show you chaos GPT because I haven't set up the Kaggle data downloads, is it can create these errors and then you put this normal Kaggle agent to the rescue. And we will watch this Kaggle agent try to fix these bugs and run the code without errors. And then when it succeeds, we add this to a data set of successful chain of thoughts. And then we can have this for real live environments that are representative of actual data science scenarios. And we can feed that to Llama, and hopefully that's a fantastic data set. Let's check up on how our model is doing. Oh, it's running the notebook. Yeah, sorry about this. Okay, in this case, no news is good news, because Jupyter notebooks in this very hacky, through a container scenario, they don't give you their output until they're done. So I'm going to actually make it cause an error. I'm going to Control-C, keyboard interrupt. Let's see if this, hopefully this shows us. No, it seems like, okay, anyway, no news is good news. This was running, even if you couldn't see it, I promise. The idea is with better output, you can make an automated data set at a very large scale.
Here's what the VS Code color theme is. That's really cool.
Oh, this is jellyfish.
What did a company where that was it?
What kind of model did it try to run on MNIST? Why did it, is it taking long? You said it's going to take long in this environment. Is that just like a byproduct of what you have, or did it just try to run a huge model?
Well, let me tell you about this environment. This environment is my computer. There's no GPU on this. This is this is running in some environment with it has no GPU access. This specific, the code I use to run Jupyter notebooks is doing a double layer export. It's running it inside of a second process. It's really slow. It's sort of the biggest problem I have to deal with. So what does this model look like? It's just sort of like a 4-layer MLP.
Will this model be able to compete on Kaggle?
Probably not. It's probably going to be pretty crappy.
So one of the most aggravating parts about Kaggle is just loading the data. As if you figure out how to do that for kind of the more complex data sets, or do you think it would be able to?
Okay. First, no. The part that I can download from Kaggle is just the people's notebooks that they've made. I think there are enough notebooks on Kaggle, public notebooks, that I can just throw away the ones where the default Kaggle CLI download fails. And there will still be enough left to be a good training data set for reasoning. All right, thank you.
Awesome.